Hello everyone, welcome to the part 6 of the Know About Electronics series. I hope so you are enjoying and taking advantage of this series, and thank you for your responses. Do the share, subscribe and like my channel as more as possible, so you will get the advantage of it and also others will get that advantage also. So in the last lecture we have seen that semiconductor having two types: intrinsic semiconductor and extrinsic semiconductor. Intrinsic means pure semiconductors and extrinsic means impure semiconductor. In pure semiconductor we are having the examples like silicon, germanium. Okay, that means what? That pure semiconductor does not having any mixing of the materials. Okay, that's why it's called as a pure semiconductor. And impure means suppose there is a two materials are there and they are going to be mixed with each other, that will create the impure semiconductor. Okay, here we have written as the at 0 Kelvin, or 0 Kelvin means minus 273 degrees Celsius, the intrinsic semiconductor acts as an insulator. Means at a 0 Kelvin it does not allow the current to flow through it. Okay, so we will see the first part, that is the intrinsic semiconductor. Okay, in intrinsic semiconductor the intrinsic charge is calculated as intrinsic charge, known as Ni, intrinsic charge. Okay, Ni, there is a one equation for it that will helps you to solve the examples also. A T cube E minus Ez0 divided by kT. Okay, here Ez0, in the last lecture we have seen that energy gap at 0 Kelvin. Okay, Ez0, K is a constant, T is in temperature in a Kelvin, A is also constant, and here K is a Boltzmann constant and A is a constant. Okay, so we have to see here what is the relation is between intrinsic charge and the temperature. So just take the term of the temperature into this, that is directly proportional to T cube Ni square. Therefore Ni is directly proportional to T cube by 2. Therefore Ni is equal to T raised to 3 by 2. This is the relation between the intrinsic charge and temperature. Okay, as increase the temperature, the increase in the temperature, then resistance of that material will decrease. Okay, so in the next one we are going to see that the extrinsic semiconductor. Extrinsic semiconductor. In the first, what we have seen, the intrinsic charge, how to calculate the intrinsic charge, what is the relation between intrinsic charge and the temperature, and what happens if temperature is going to be increased. Okay, and now next one will be the extrinsic semiconductor. It also having the two types. First one is the P type and second one is the N type. Okay, so impurity addition to the semiconductor gives extrinsic semiconductor, and this process is called as a doping. Doping means what? To add the impurity to the semiconductor, which will give you the extrinsic semiconductor. That means here we will see, suppose here is a pure extrinsic semiconductor will be added with the impurity the process is called as the doping, means adding the impurity to the extrinsic semiconductor. So here I am drawing the orbit, okay, and out of the orbit the shells of it I have drawn. So how to distribute the electrons into these shells? There is a formula for it, that is a 2n square. Okay, n is nothing but the number of orbit, 2 1 2 3 1 2 3, as more as possible. Okay, so for the first shell I want to calculate the how much number of electrons should be there in the number 1 shell. So for the 1, 2 into n is equal to 1 square, 2 into 1, that is equal to 2. For the number 2 shells, okay, 2 into n square, that is 2 into 2 square, 2 into 2 square is a 4, and 4 into 2 is equal to 8. That means to first shell you have to put the number 2 of electrons, and in the second shell there will be the 8 electrons. Okay, I will give you the example, that is a silicon. Silicon having the total atomic number is a 14. So how to distribute it? In the first we have to take a 2 electrons, in the second you have to take a 8 electrons, and the remaining will be the 4 electrons. Okay, and for the germanium atomic number is a 32, so it will be distributed as 2 8 18 and 4. How it becomes? 2n square. For the third shell, 2n square, that is equal to 2 into third shell we are taking 3 square. 3 square is a 9, and 9 into 2 18. Okay, and the remaining will be the 4. Okay, in this way we have saw today the how the intrinsic semiconductor is going to be related with the temperature, and also we have saw that how the extrinsic semiconductor is going to be classified into the two types, and how to distribute the electrons in the atomic as per the atomic value in the shell. Okay, thank you.